Okay, here we'll provide you with a brief review of partial pressure and we'll use it to solve a problem. It's a topic that sometimes confuses students, but really it's not that bad. The basic idea is that if you have particles inside a container in the form of a gas, doesn't really matter what they are. They hit the walls, they exert pressure. You just need to know the number of molecules of each if you want to divide up the pie, as you will. The total pressure of a gas, such as air, is just the sum of the individual pressures of each substance. It's not the grams of each, since the particles will have different molar masses. It's the number of molecules of each. So for the partial pressure of each gas on the left, if you count them up, there's an equal number each, so the pressure is just coming half from each one. Since the total pressure is 1 atmosphere, each one's exerting half an atmosphere. Let's solve another problem. This is the general formula that we'll be using. The pressure is proportional to the mole fraction. All right, here's another problem. You got some neon, 4.46 moles. Oh, moles are handy. That's the number of particles. 0.74 moles of argon and 2.15 moles of xenon. Rarely will they be so nice because moles is the unit you want. Let's calculate the partial pressure of each if the total pressure is 2 atmospheres. I just find the percent of total for the each, and then that would be the mole fraction for it. So let's find out what the total pressure is. The total number of moles is 7.35, of which 4.46 came from neon. Do the same thing for argon and xenon, and you'll see that it is a certain percentage. I didn't calculate the percentage, I just left it as a decimal, and there, when you multiply it through, you find that you have 1.21 atmospheres for the neon, 0.2 for the argon, and the rest for the xenon. A nice thing about this problem is when you add it all up, you do get your 2, so you have 2 atmospheres, so you've correctly divided up the pie. This is a sample problem and a quick lesson on partial pressures.